This is Jeffrey Nemhard. This is the MEC 140 Introduction to Robotics class, and this is the midterm lab number 1. In this first lab, we're going to use a motor, which we are looking at here. We're going to use a 9-volt battery. We're going to use the Arduino circuit. We're going to be using the analog 0 and the analog 1 input. We have a diode, we have a potentiometer, we have a temperature sensor, and we have a battery tied into this circuit. And what it will do is that we have a threshold due to the temperatures being cooler. I've used a lower threshold of 25 to activate the motor. So right now the current temperatures are not high enough to activate the motor. I'm going to turn the potentiometer up so that you'll see that the temperatures right now are under 25 in the Fahrenheit. In fact, they're now in the minus. And what we're going to do is we're going to try to rise the temperature up. Once it reaches a threshold of 25, then the gauge will kick in and the motor will turn on. So what we're going to do is we're going to watch the temperature of the motor. And you see now we're in the lower 20s. We're going to try to get, and as you see the motor has now kicked in. As you see the numbers have gone temporarily above 25. So as you see the motor is now kicked in, you can hear the motor. And you see the motor is now actually running. And if I turn the potentiometer up to a higher value, the motor will continue at this pace. But as you see the temperature's changed, the motor has also now changed its pace also. So now the temperature gone above 25, you see that the motor is now going at a higher pace because I've changed the potentiometer. So that is the first circuit in lab number 1 that shows the connection between the motor and the potentiometer and the temperature sensor. And again, there you see the temperature is now below, so it's not doing that. But that is part 1. This is Jeffrey Nemhard, and this is lab part 2 of the MEC 140 Introduction to Robotics midterm. In this one we have a liquid crystal display that has been tied to a potentiometer. And what we've done in this is we've written to the potentiometer to give the measurement of what the potentiometer is set to, and at the same point it's going to send a message on the screen. As you see, the hello world message is set on the screen and the potentiometer value is listed under it. Right now we're going to change the potentiometer slightly. And as we see, the value of the potentiometer should be a different value. And as you see, it has changed to a different value. Now if we're going to reset it again to another value, and again the potentiometer shows its new setting and new value. So what is happening here is the LCD is just not just displaying a message, but it's also displaying the value that is being read off of the potentiometer based on a read of the analog. And the code that you see is displayed shows how the potentiometer has been initialized and how we go through. We set the settings for the liquid crystal. We've also set the LEDs for the message, and we set a loop that will go through and send the message, hello world, and then it clears the message after a 3-second delay, and then it gives you the reading of the potentiometer, and then after a 3-second delay it clears itself again. So that is part 2 of the midterm. This is Jeffrey Nemhard, and this is the MEC 140 Mechatronics Introduction to Robotics, and this is the midterm lab part 3. In this exercise, the potentiometer has been replaced now with a thermometer, which is now measuring the temperature of the air and then displaying that temperature as the Fahrenheit scaling And as you see it on the Arduino board, you see that it is now displaying the temperature. It has a 3-second delay between the heading and then the temperature reading. But you see it does read that temperature gauge, and it refreshes at 3-second intervals before it flashes again the new temperature readings. I'm trying to get a clear focus on that. That looks clear. So we have that. The temperature. And you see as each renewal the temperature is slightly varied from the last setting. That concludes part 3 of the lab. I'm just trying to get it clear to show the code, and that's used just by changing the code to include. If it doesn't show here, the code has now included the temperature as part of its scaling to now add to electricity. You can see the code written there. See the adjustments. Yes, there. That's out of focus there. And that's part 3 of the midterm lab, for which we're going to measure the temperature scale. So this is Jeffrey Nimhart for the last part of the midterm lab, part 4 for the MEC 140 Introduction to Robotics. And in this we have a setup where we have the VEX shield is now attached to the Arduino. We have what we have as a forward button, back button, and we have the motor attached to a shaft that allows you to see the motion of the motor, attached to a 7-volt battery. And what's going to happen in this video is that if you are to hit the buttons, these push buttons, they will cause different actions to occur. First, if you hit the forward, then there will be a clockwise motion of the motor. And if you hit the back button, there will be a counterclockwise motion of the motor. And as you see, when neither button is pressed, nothing happens in terms of there's no motor action. And also when both buttons are pressed together, there should be no motion of the motor. So we're going to put these buttons together so we can show that. And we're going to press them at the same time. And as you see, nothing occurs. But if I do one or the other, but when they are together, pushed, there is no motion in the motor. And that's an example of using the potentiometers and using the buttons and using the VEX motor and using if and whiles to create a conditional situation upon which you can control the movement of the motor. So again, that's counterclockwise, clockwise. This, as it is done through. See if we can get a focus on this, a little better focus on the code. You can see where the motors are set. We use a pull-up resistor that's built into the Arduino board. And we set the motion based on the button combinations. We change the states to know whether these button would be forward or back based on the state of the code that was checking it through a while loop and an if statement. And that concludes the midterm part 4.